Chapter 8. The Story of Life and Organism. We have understood a lot of facts about the characteristics of life and living beings. The question how and when life and living beings were formed in the world have confused man from the ancient period. This chapter enables the children to identify human beings as a group in the path of evolution, to understand how the nature works, and to make the children aware of the damage caused to biodiversity due to the indiscriminate activities of human beings. The only known planet to have life is Earth. An important aspect of Earth is gravity. Due to the gravitational force, natural gases began to surround the Earth. This in turn created the Earth's natural atmosphere. The origin of life theories were first set forth by a Russian scientist, Alexander Oparin, in 1924. During this time, J.B.S. Haldane, an English scientist, also arrived at a theory for the origin of life. Gases like hydrogen, ammonia, water vapor, and methane, which were present in the atmosphere of primitive Earth, reacted together to form simple organic molecules like amino acids. This was the result of chemical reactions that took over thousands of years. Lightning, ultraviolet rays from the sun, volcanic eruptions, etc. favored this by providing the high energy required for these reactions. Following this, the water vapor present in the Earth's atmosphere cooled, causing rain for millions of years. This resulted in the formation of oceans. Organic molecules formed in the atmosphere by the reactions of inorganic compounds dissolved in rainwater and reached the oceans. They further reacted with one another to form more complex molecules. In this way, due to changes over millions of years, the first form of life originated on Earth. Another theory of the origin of life that is popular today is panspermia. It states that life was created by distribution of organic particles by planetary objects like meteors, comets, etc. The geological time scale is one table that explains about the origin of life. The simpler cells of the new living things evolved into the more complex multicellular organisms by the process of evolution. The scientist Jean-Baptiste Lamarck was the first to formulate these thoughts on evolution in the form of a theory. Use or disuse of organs depending on living condition changes in the structure of organs. These changes are transmitted to the next generation and form new species of organisms. The classic example used to explain the concept of use and disuse is the elongated neck of the giraffe. According to Lamarck's theory, a given giraffe could, over a lifetime of straining to reach high branches, develop an elongated neck. He also gave the example of snakes in support of his postulate about the disappearance of organs due to disuse. According to him, snakes evolved from the quadrupedal reptilian ancestors which lost their limbs through disuse. These animals were forced to crawl on their bellies into burrows when limbs were not of much use. And their disuse led to the evolution of the species of snakes without limbs. Lamarck's concept is called the theory of acquired characteristics. Charles Darwin, the famous naturalist, presented the evolutionary theory through almost logically through scientific research. During his voyage, the geographical area which influenced and helped Darwin the most was the Galapagos Islands. The different species of finches found in these islands led him to think of evolution of species. There are 13 types of finches in 15 islands. Finches which were similar in sound and nesting habits showed differences in food and food habits. Galapagos tortoises and iguanas were other examples of Darwin. Analyzing the informatics collected during his voyage, Darwin formulated theory of evolution which he presented in his book The Origin of Species. Each living organism is concerned with reproduction and sustaining their species. Mass reproduction in animals leads to scarcity in resources such as food, shelter, mate, etc. Hence, animals compete with each other severely in order to survive. This is the fight for survival. All living organisms undergo evolution and change in a constant way. These changes may be advantageous or disadvantageous. Positive evolutionary changes make certain species stronger and more resilient to negative changes. Charles Darwin calls this evolutionary phenomenon as survival of the fittest. Evolutionary changes which are in harmony with a changing environment produce better survival rates and creation of newer, more adaptable life forms. The British naturalist Alfred Russel Wallace also arrived at Darwin's inferences on evolution. Studies conducted in the Indonesian islands, etc., led him to this. The scientist Hugo de Vries postulated a theory which states that sudden and heritable changes lead to evolution. This is known as mutation theory. Fossils are remnants as traces of organisms that lived in the past preserved in the earth crust. The branch of science which deals with fossils is called paleontology. Fossil studies provide a lot of information about ancient organisms and the direction of evolution. Fossil of Archaeopteryx, which has both the characteristics of reptiles and birds. Fossils of woolly mammoth, the fossils of human ancestor Java man are more examples of evolution. We have understood that life evolves from simple single-cellular organisms to complex multicellular organisms. Like other organisms evolved, man also has structurally evolved through time. These positive changes have led to the development and progress of the modern man. Primates are the common group that includes man and monkeys. The main features of primates are 5 fingers in arms and legs, flat nails, opposable thumb, eyes that can be focused simultaneously on one object, a pair of nipples. Primates are classified into 2 groups, prosimians and Cercopithecodidae. The Hominoidae group, which consists of humans and chimpanzees, were evolved from the group Cercopithecoidae. Not only fossil studies, but comparison with the organisms which are considered as closely related to man in evolution have helped to draw inferences about the direction of human evolution. A branch of science which analyzes the phenomenon of life at the level of molecules is known as molecular biology. The living body is made up of many biochemical molecules. The difference in the arrangement of these molecules in proteins and genes of organisms would help us to understand the distance between them in the phylogenetic tree. Globin is the protein part of hemoglobin that gives blood its red color. Hemoglobin consists of two alpha chains having 141 amino acids and two beta chains having 146 amino acids. Amino acids in the alpha-beta chain are different in each species. The difference between the hemoglobin B chain of the gorilla and a human is only one amino acid. In chimpanzees, however, there is no change in the hemoglobin B chain. Hence, in evolution, the chimpanzee comes very close to a human being. Research studies to find connections in evolutionary links is one through the aid of fossils. The history and progression of human evolution would become more clear with the discovery of more and more fossils. Dryopithecus are animals which is considered as the common ancestor of man and chimpanzees, supposed to have lived from 20 million to 14 million years. Ardipithecus are the first ancestor of man, who is considered to have lived 4.4 million years ago. Australopithecus fossils were discovered from Southeast Africa. These ancestors of man were considered to have lived 3 to 3.2 million years ago. Homo habilis are the oldest fossil of the genus Homo, which expresses the biological and behavioral characteristics of modern man. Their fossils were discovered from the Olduvai Mountains folds of Tanzania. Considered to have lived from 2.25 million years to 1.44 million years ago. Homo erectus considered to have lived 1.8 million years ago. In 1976, the full skull of Homo erectus was discovered from Eastern Africa. They are supposed to have good intelligence and physical. The Homo neanderthals and Cro-Magnon later evolved to form Homo erectus. Homo neanderthalensis were considered to have lived from 50,000 to 30,000 years ago. The Cro-Magnon stage in evolution is also considered to be the dawning of cultural progress. There is a possibility that human beings will undergo evolutionary changes based on new physical conditions in the future. Due to modernization and technological discoveries, it is difficult to predict where the human evolutionary trends is heading towards.